Today we're doing 10-4, which is the algebra of matrices, and we're going to perform operations on matrices and solve the equations. So you guys just read about how matrices are equal if they have the same entries and the same position. So if we're finding A, B, C, and D, since 1 is in the position for A, we know A is going to be equal to 1, B is going to be equal to 3, C is equal to 5, and then D is equal to 2. Then we read about how you can add or subtract if they have the same dimension. And if they're not the same dimension, then we'd say that that's undefined. So you're just going to add or subtract the corresponding entries together. And then you can also multiply by a scalar, and that's called the scalar product. Really, when you're multiplying by a scalar, you're just multiplying by what? What is a scalar? What's another name for a scalar? Which one of these were you multiplying by a scalar? Okay, so 5 is just a constant. Yeah, so that's what you're going to be multiplying by. So when you're multiplying A and B, you multiply 2 plus 1, and what'd you get? 3. Negative 3 plus 0. Negative 3. 0 plus negative 3 is negative 3. 5 plus 1 is 6. 7 plus 2 is 9. Negative 1/2 plus 2. We're going to leave that as a improper fraction. So it'll be 1/2, which is going to be 3 over 2. Okay, and then both of these matrices are 3 by 2. So a 3 by 2 and a 3 by 2, we can add those together. Okay, for B, we're doing C minus D. Okay, so if we're doing C minus D, I have 7 minus 6, negative 3 minus 0, 0 minus negative 6, which turns into what? Positive 6. 0 minus 8, 1 minus 1, and then 5 minus 9. Okay, so that's what your result should be. Let there be light. And then we're going to add C and A. But what's the problem with that? Right, so C is a 2 by 3, A is a 3 by 2. Okay, so then what we would say is this is undefined. Okay, so they're undefined because they do not have the same dimensions. So we cannot add them together if they're not the same dimensions. And then the last one, you're just going to multiply by the scalar. So I'm going to multiply everything by 5. So that would give me 10, 0, 35, negative 15, 25, and negative 5 over 2. Okay, any questions for me on the first page? Ready for page 2? Oh yeah, go ahead.
Why do you leave it as a fraction?
That, I just like it better. If you wrote it as a decimal, I wouldn't work it wrong. That's just how I prefer it. Okay, so the properties that we're going to look at next are going to apply to addition and scalar multiplication. And the reason why these are important is as we go on in our notes today, you're going to see that not all operations have these properties. So with addition and subtraction and scalar multiplication, they're commutative. So if you add A and B together or B and A, you're still going to get the same answer. It's associative, so it doesn't matter the order in which you add them together. And then the scalar multiplication follows the associative, so the order doesn't matter in which you multiply them. And then you can also use the distributive property. For example 3, we're going to solve the matrix equation. So here's my matrix equation, 3x minus 4a equals b. And step 1 says solve the equation for x. So I'm going to give you some time right now to do that. Okay, so you're going to solve the equation for x. first step, Isabel, what did you do first? Okay, good. So we're going to add 4a to both sides. Now, because this is commutative, you can decide the way that you want to write this out. So I'm going to write it as 3x equals 4a plus b. But if you write it as b plus 4a, that's perfectly fine. Now, when we get to this step, we're probably thinking, oh, you divide by 3. So with matrix operations, we're going to multiply by 1/3. Okay, so we're going to multiply both sides by 1/3. So multiply by 1/3. Multiply by 1/3. Okay, which will give you x is equal to, and then I'm just going to write this as 1/3 4a plus b. Now, if you wanted, you could also distribute, and you could calculate 4/3 a plus 1/3 b. Okay, you could do that. I think this is going to be the simplest because then I don't have to distribute two fractions. Okay, but you can really pick whatever order you want to. So in step 2, it says to plug in the matrices and evaluate. So I have x equals 1/3 4a plus b. Then what I'm going to do is just substitute in my values. So I have 1/3, and then it's going to be 4 times matrix A, which is 4, 3, negative 1, 2, plus B. And then you just have to follow your order of operations. So before you can add these together, you're going to have to multiply this matrix by 4. Now this part is usually something that you would do in your head. So 4 times 4 is 16, 4 times 3 is 12, negative 4, 8. Okay, so then I want you to finish that, and then will you just check your answer with your elbow partner? Okay, so when we added these two together, we should have got 3, negative 3, 9, and 6. And then really you're dividing everything by 3. So you have 1, negative 1, 3, and 2. Right? And then that's going to be your final answer. And then you just solved a matrix equation. Okay, how do we do? Good? So far so good? Alright. Now, the next thing we're going to talk about is matrix multiplication. So, matrix multiplication is a little more complicated, but that's not really saying much, is it? So far, it's been pretty chill, right? Just adding the same entries together. So, multiplying two matrices is more difficult, and then we'll go over that in some later examples. But before we describe it, there's a couple of things we have to identify first. So if you can even find the product, then what has to happen is the number of columns in A has to be equal to the number of rows in B. Okay, so the columns in A have to be equal to the number of rows in B. So if we put the dimensions side by side, you'd see that these two match. In fact, the way that I usually write it out is I'll say, oh, the first matrix is M by N, the second one is M by K, and then I'll just match these two together. So if they match, I'll put a little check mark. Here I'm just going to put match. Yep. Okay, and then the result matrix is going to be the rows and the columns. So the result would be an M by K matrix. So this says that AB is a matrix of the dimension, and it's going to be an M by K. Okay, so that's going to be the rows of the first one and then the columns of the second one. Sometimes it's kind of hard to wrap our head around if you have arbitrary numbers, so let's look at it with some real values. So let's say I want to multiply a matrix that's 2 by 3 by a matrix that's a 3 by 4. So then what I would do, if I can, I would match these together, which they do, 3 and 3, and then your result matrix would be what dimension? The result would be a what? 2 by 4, right? So 2 by 4 here. Okay. Now, before we talk about the procedure, we have to define something that's called the inner product. Okay, so the inner product of row A and column B. And that's continued on the next page. Okay, so we're going to define the inner product of row A and column B. So they give you, it says if A sub 1, comma, A sub 2, all the way up to A sub n is a row of A, and B sub 1, B sub 2 to B sub n is a column of B, then their inner product is this number. And that number is A1 times B1 plus A2 times B2 all the way up to AN times BN. So let's look at this. A1, B1. That means I'm multiplying the first term of the row by the first term of the column. And I'm adding that by the multiplication of the second term in the row times the second term in the column. So it's kind of similar to what other product? Other one. The dot. I was thinking the dot product, right? Because in the dot product, you're multiplying the two together and then adding them.
The cross product is a bunch of dot products.
Well, yeah, that's true. Except you're subtracting them. You subtract them instead of add them. But you're thinking vectors, right? Hey, so we're gonna do an example real quick with these two matrices. Okay, so after we actually do this, I'm gonna show you how you can line up the matrices. So you're gonna multiply this row by this column. So the first element is 2. The first element of the column is 5. So we're gonna multiply 2 times 5. And then we're going to add that to the product of -1 times 4. And then, Drew, what two numbers am I going to multiply together next? Okay, well, let's see what I just did. So I did 2 times 5, the first times the first. And then -1 times 4 was the second times the second. Okay, so what's going to be my next one? Yep, so what times what? What's my third and my third? Yep. Okay, and then Hayden, what are the last two I'm adding together? Yep, 4 times 1/2. Good. Okay, so then I'm going to have 10 minus 4 plus 0 plus 2. 10 minus 4 is 6. 6 plus 2 is 8. Right? Now, this is a 1 by 4 matrix. And then, Julia, what kind of matrix is this? What are the dimensions of that matrix?
4 by 1.
Yep, a 4 by 1. So if we line these up, a 1 by 4 and a 4 by 1, 4 by 4, those are going to work. And then your result would be what matrix? A 1 by 1 matrix. Okay, so your 1 by 1 matrix only has one element, and that element would be 8. Sorry, that's a weird looking 8. Do it again. Okay, so that would be your final answer. So here's how the book defines your matrix multiplication. If you have a matrix A and a matrix B, their product is going to be the M by K matrix, which we call C, and it contains the elements Cij. And then Cij is formed from the inner product of the ith row and the jth column. So that's a little bit confusing, but let's remember what we know about the ith row and the j column. Remember when we were doing the entries and we were doing like 1, 1, 1, 2? So the I represents the row, the j represents the column. We're going to look at this in a different format. So if this is the ith row and the jth column, okay, this is where your entry is going to go. We're just going to add some specifics to it. Let's say this is the second row. Okay, if we multiply the second row by the second column, then that means the sum, that inner product that you found, is going to be C22. Okay, and that's the inner product of the second row, second column. Okay, so we're going to calculate some of these together for example 4, and then I'm going to kind of let you do some on your own. So we're given A and B. We have to calculate A and B and A times B and B times A if possible. So the first thing I'm going to do is try to calculate A times B. So what I have to do is identify what their dimensions are. So Jordan, what's the dimension for matrix A? Other way around.
3 by 2.
Yeah, so it'll always be the rows first. So 3 by 2, and then B is a 2 by 2. So we can multiply these if the inner numbers match. So they do match. And then the outside numbers is going to give you what your result is going to look like. So when I multiply these together, I'm just going to rewrite these out, because we're going to be writing on them. So this is matrix A, and this is matrix B. Okay, and then it is going to result in a 3 by 2 matrix. So a 3 by 2 matrix. Okay, you guys with me? So I'm going to have you just watch the first couple, and then I'll give you time to write it down. Okay? So if you're multiplying the first row by the first column, this is going to be C11. So if you want to write down the C11, you can. So the first row, first column. And then what I usually do is I keep my hand here just to keep me focused on what I'm multiplying. So I'm going to take 4, which is the first element in the row, times -1, which is the first element in the column, and then I'm going to add that to 1 times 3. Okay, so I have -4 plus 3, which is going to be -1. So that's going to go in the first row, the first column. So now I'm going to do the first row, the second column. Okay, so this is the first row, this is the second column. So now I'm multiplying 4 times 2. and I'm going to add that to 1 times 1. So the second and then the second. Okay, and then 8 plus 1 would be 9. So then when I'm going to put that in my matrix, I say, okay, I want the first row, the second column, and that's where I'm going to substitute it in. You guys want to do one more together? You think you can do the second one? Okay, so now that I've done the first row, now I'm going to go to the second row, and I'm going to do the first column, and then I'm going to do the second row, the second column. Okay, so now I'm going to underline this one. So I'm going to multiply negative 3 by negative 1. So negative 3 times negative 1. And I'm going to add that to 0 times 3. Okay, so I want you to see if you can fill in the rest of those. And then we'll check back in just a bit. Okay, how did we do? Yep, good. And then some of you finished and went on to B times A, so that's good. So for your second row, your second column, you should have negative 3 times 2 plus 0 times 1, which is going to give you negative 6. So the second row is 3, negative 6. Okay, and then here you have 2 times negative 1 plus negative 1 times 3. And then the next one is 2 times 2 plus negative 1 times 1. Okay, so this will be negative 5. This will be 3. And that will give you your final row. Okay, so then this would be your final answer for A times B. Okay, so negative 1, 9, 3, negative 6, negative 5, 3. Alright, and then for the second one, we're going to do B times A. So the first thing we have to do is make sure that this is allowed. So B is a 2 by 2, A is a 3 by 2. Remember, if these do not match, then we can't multiply them. And then what would we call this? Undefined. Okay, so this is going to be undefined. And the reason why is the number of columns in A is not equal to the number of rows in B. Okay, so when you're doing this, whichever one comes first, that's the one that you're using the rows for. So it's the row first and then column second. All right, you guys ready for the next page? Okay, so although your matrix although matrix multiplication is not commutative, it does obey the associative and distributive properties. So matrix multiplication is associative and distributive. Okay, so with associative, it doesn't matter if you multiply 2 and 3 and then multiply the first one by that product, or if you multiply the first two together, then multiply by the third one. And then you can also distribute. What you know is not equal is A times B is not equal to B times A. We just saw that with the last one because we could find the product of A times B. We couldn't even find the product of B times A. That's why we say it's not commutative. Okay, now even though that one was undefined, even when you can find both of them, when they're both defined, they still are not necessarily equal. And that's going to prove to us that matrix multiplication is not commutative. Okay, so what I want you to do is I want you to calculate the products A, B, and BA. Okay, so I'm going to give you some time to do that. So you're going to multiply A times B. Now A and B are both what type of matrices? 2 by 2, which means their result is going to be 2 by 2. Okay, so I want you to multiply these together. I'm going to give you some time to do that. Not time to take a nap or daydream. And then I will come around and help you in case you have some questions. check this? Alright, so for your first row, first column, you're going to be multiplying 1, 2 by 6, 2. So 1 times 6 is 6. 2 times 2 is 4. So that's going to give you 10. Right? That go okay? And then first row, second column. So 1 times 0 is 0. 2 times 3 is 6. So that's going to give you 6. And then your second row, first column. Negative 1 times 6 is negative 6. 4 times 2 is going to be 8. So that's going to give you 2. And then second row, second column. Negative 1 times 0 is 0. 4 times 3 is 12. Okay, so you should have 10, 6, 2, 12. Okay, and that is the result of A times B. Okay, now when you're doing B times A, were you able to find B times A this time? Yes, because B and A are both 2 by 2s. So the 2 by 2 and the 2 by 2 is still going to match up to a 2 by 2. Okay, do you guys like writing them out so that you can follow along with them, or do you feel like you do okay without doing that? It's not that it's difficult, it just takes some concentration, doesn't it? Okay, so 6 times 1, which is 6. 0 times anything is 0, so 6 is going to be your first row, first column. And then your first row, second column, 6 times 2 is 12. 0 times anything is 0, so you're going to have 6, 12 for your first row. And then your second row, first column is going to be 2 times 1, which is 2, plus 3 times negative 1, which is negative 3, so that's going to give you negative 1. And then second row, second column, 2 times 2 is 4, 3 times 4 is 12, which will give you 16. Okay, so then this is your B times A. So it's pretty clear that those are not the same matrix, right? Okay, so we know that it's not commutative. So the order in which we multiply matrices together is going to matter. So that's why when we come to example 6 and we have to calculate AHC, there are a couple different ways we can do that. We could either multiply A times H first and then C, which is going to be the most common way. Right? It's also the way I would recommend. Or you could also multiply A by HC. But when you do that, notice the position of A. See how A is on the left side? When you set this up, when you line them up, A would still have to be on the left side. Now, eventually, we are going to get to a place where you can use your calculators too. So if you were to multiply H times C first, and then in your calculator just type times A, you get an error because you'd have to type A in first and then multiply it by HC. Okay, so keep in mind that this is not the same as HC times A. Okay, you cannot multiply that way. Right? Now I'm thinking naturally you would do this anyway, your AH times C, but before you go through all that work, what I would do is check to make sure that it's defined. So A is a 2 by 2 matrix. H is a 2 by 2 matrix, so I know I can multiply those together and I would get a result that's a 2 by 2. But then let's also make sure that C is going to fit in here. So C, Ella, is what kind of matrix? What's the dimension for C? 2 by 3. So if it's a 2 by 3, the 2's are going to match up, and then your final answer is going to be a 2 by 3. And the reason why I tell you to do that first is if you're doing your homework, I don't want you to multiply A times H and then the next step get to undefined. If you can see that it's undefined right here, then that's just going to save you some steps. Alright, so then let's multiply A times H together. So I have 2, 0, negative 5, 7 times 3, 2, 1, negative 1. And then I like to put what it's going to equal. Okay, and I'll give you a minute to give you a head start on that. Yeah, on example 3, I should have wrote this there, but this should say B equals and it doesn't. So sorry, we just assumed that was B, but that will say B equals. All right, how did multiplying go? So first row, first column. I'm just gonna show you how you can do this quickly. So like you'll be multiplying the first part in your head, right? 3 times 2 is 6. This would be 6 minus 10, which is going to be negative 4. So then you're just going to put that in your matrix. For 1, 2, 2 times 1 is 2. Negative times a negative is a positive, so that will be 7, right? And then the second row, first column, 0 times anything is 0 plus 14. And then for the second one, it'd be 0 minus 7. So this one would be 14, and then this one would be negative 7. Okay, so that's going to be your A times H. So now, when you do AH times C, you can write out negative 4, 14, 7, negative 7, times C, which is 2, 0, negative 5 over 2, 2, and then 0, negative 3. Okay, so we're going to do the row by the column. And then this one's going to be just a little bit longer. So we know this is going to be a 2 by 3. So first row, first column, negative times a negative is negative times positive is a negative, plus 0. So this will be negative 8. First row, second column. Whenever you're multiplying a fraction, like negative 4 times negative 5 over 2, you multiply by the top, divide by the bottom. So negative 4 times negative 5 is 20. 20 divided by 2 is 10. And then plus 14 will give you 24. And then this one has a third column, so you're just going to continue in the same fashion. So that would be 0 plus negative 21, which will give you negative 21. Okay, so now we're going to go second row, first column. So 14 times 2 is 28. The next one's times 0, so we're just going to have that 28. 14 times negative 5 over 2. If I'm doing 14 times negative 5 over 2, I want to do 14 divided by 2 first, which is 7. So 7 times negative 5 is negative 35 minus 14, and that's going to give you negative 49. And then your second row, your third column, would be 0 plus 21. So then that's going to be your final answer. So that's going to be your AHC. Is negative 8, 28, 24, negative 49, negative 21, 21. Okay, and then your homework is going to be page 669. This is 10-4. And you're doing 7 through 33 odds. And then number 33, you only have to do part A. Okay, and that's for 33 only. Okay, make sure you guys are showing work where you need to. This stuff you really don't have to show too much, but on yesterday's I noticed some of you just wrote down the answers to the odd ones, which are in the back of the